Okay, this is Alligation lecture video 5. And what I want to do in this lecture video is that I want to put all of what we've learned from concentrations, dilutions, and alligations and put it together and read each problem and determine what type of problem it is and what steps we need to take in order to solve it. So in order to do that, I think we need to start on page 547, and I'm just going to pick out a couple of problems from our post-test, and we're going to start with number 1. I think number 1 is a good starting point. So on page 547, number 1 from the post-test, it says, how many grams of dextrose must be dissolved in sterile water to prepare 100 milliliters of a 60% solution? All right. So the first question you ask yourself is, what type of problem is this? By reading this problem, how many grams must be dissolved in sterile water to prepare 10 milliliters of a 60%? The first question I ask you is, how many concentrations do you see? Well, while I read the problem, I've only read that there is one concentration, which means that this is starting off, it's a concentration problem. Because remember, a concentration problem only has one concentration. It can be expressed in a ratio, a fraction, or percentage. In this case, it's expressed as a percentage. If you have two concentrations, regardless of how they're expressed, ratio, fraction, or percentages, is considered a dilution problem. And if you have three concentrations, regardless of how they're expressed and presented to you, whether it's a ratio, percentage, or a fraction, is going to be considered an alligation problem. So moving on, because I know it's a concentration problem, the next question I'm going to ask myself is, what type of concentration is it? Well, if I'm trying to figure out how many grams is in 10 milliliters, then grams is weight and milliliters is volume. So this is what? A weight to volume, which is grams per milliliter type of concentration. So now I've determined what type of concentration it is. So now I need to ask myself, what is it that I'm looking for? It's a concentration problem. So in a concentration problem, you're either looking for your active, your total, or your percentage. Well, because I'm looking for how many grams, and grams is going to be what? Is at the top here. That means I'm looking for my active, because your total is always your bottom. So I'm looking for active. So I'm going to use my formula where I take X over the total, which is 10, equals my percentage, which is what? 60 over 100. I'm going to crisscross multiply. So that's going to be what? 100x equals 6,000. I'm going to divide 100 on both sides. And my answer is going to be X equals 60 grams. All right. So 60 grams dissolved in 10 milliliters is going to give me a 60% solution. All right, let's try another one. I'm going to erase this little bit here. So let's look at number 2. All right, number 2 says if there is 15 milligrams of amoxicillin added to 100 milliliters of sterile water, they want to know what is the percent strength What is the percent strength of the total volume for the prepared medication? All right. So they are asking you to find the percent. So the first question I'm going to ask you is, what type of problem do you think it is? Well, I only see one concentration, and technically I'm finding that concentration. So this is a concentration problem. All right. The next question you ask yourself is, what type of concentration? It says you're adding 15 grams to 100 milliliters, or 15 milligrams to 100 milliliters, which means this is a weight to volume problem. And remember, weight to volume, it must be in grams per milliliter in order for you to manipulate it in any form or fashion. All right. So the next step you need to ask yourself is, what is it that I'm looking for? Well, it tells you what is the percentage. So you're looking for the percent. In order to find the percent, you have to take your active over your total and multiply it by 100. So my active is my weight. All right, my weight is in 15 milligrams, but remember, it has to be in grams. So you have to change 15 milligrams to grams. So if I change 15 milligrams to grams, that gives me 0.015 grams over the total. My total is my volume, all right, which is 100 milliliters. And then you multiply it by 100. Well, of course, that cancels out. Those two 100s cancels out. So that means your percentage is 0.015%. That is your answer for number 2. Well, let's try another one. I start off with a whole new page here. Well, let's do number 4. Let's turn to page 548 and let's look at number 4. Number 4 says that you have a lotion of 5%. All right. A lotion of 5% is to be prepared for a patient. And it's asking you what amount. They want to know what amount of a 10% should be necessary to prepare an 8-ounce. So it says 5% is to be prepared for a patient with allergic dermatitis, and it says what amount of a 10% solution should be necessary to prepare the 8 ounces. This one is very interesting. We're gonna skip that one, darn. All right, I think we can solve this one without a problem. We just have to kind of read it correctly to make sure we are following it correctly. So, first question we ask ourselves is, what type of problem is it? Well, I've been given 2 percentages. I've been given a 5% and a 10%. So if you're given 2 concentrations, then you guys know that it is a dilution problem. All right. So then the next question you ask yourself is, what is it that I'm looking for? Well, the question is, what amount of a 10% is needed to prepare 8 ounces? All right. So you're looking for either Q1 or Q2. Well, I'm going to tell you now, you're looking for your Q1. You're looking for your Q1 because your Q1 is what? The stock quantity. Your highest concentration is this 10%. You're looking for the quantity that goes with that 10%. So we're going to use our dilution formula where it's at C1 times Q1 equals C2 times Q2. Well, I know that my C1 is that 10%. My Q1 is X because it says what amount of a 10% do we need to prepare 8 ounces. My C2 is that 5%. And my Q2 is that 8 ounces. That's what I'm preparing. All right. And in this case, it's a lotion. So that means that your ounces needs to be in grams. So 8 ounces is 240 grams. So go ahead and solve the problem. So that's 10x. 5 times 240 is what, 1200? You're going to divide 10 on both sides, and x equals 120 grams. So I'm going to need 120 grams of the 10% to prepare 240 grams to make a 5% lotion. That one started off a little tricky, but we were able to solve it. We know that it's a dilution problem. I'm looking for my Q1. With your dilution problems, once you identify your components, all you have to do now is just plug and chug. All right? Just plug it into the formula and chug it out. All right. So I'm going to stop here, and I'm going to pick back up in lecture video 6 with some more of these post-test problems, just so we can continue to practice.